Sir,
Yeah, good evening, everyone.
Good evening.
so to do in today's class.
Yeah,
So what are we going to do today?
okay. In the last class, we completed one of the chapters from chemistry. I think we completed chapter 1.
Yes, sir. Chapter
Yes, sir.
1.
Okay. So we have revised 2 chapters. We have revised chapter motion. We have revised 1 chapter from chemistry also. Now we'll be revising chapter force and laws of motion. Since most of you face problem with the chapter force, okay, so we'll start with the force and laws of motion.
Okay, sir.
All right. I hope you are able to see the screen.
Yes, sir.
So this chapter is, we are currently on chapter force and laws of motion. Alright. So our first chapter, it describes motion, right? First chapter describes that what types of motion are there. Okay. And we can predict the position or the state of motion of a body at any interval by using those. So in the first chapter, what we have studied is description of motion. Okay. So we have described motion using certain variables. Okay. So motion description, we have described the motion with the help of motion description has been described with the help of
Force.
position, no,
Position. Yeah.
position, displacement,
Distance.
distance.
Acceleration.
Yeah, so position, displacement, distance, time,
Acceleration.
velocity. We have
Speed.
time, velocity, speed, okay, and acceleration. So these were a few of the variables which we used to predict motion in the previous chapter. So with this, we could predict motion,
Yes,
like
sir.
what will be the state of a body at a given after a
Yeah.
given interval of time. If we know a certain situations, so we could predict that what it will be after some interval of time. Now this chapter, see, it's laws of motion, so it governs the motion. That means it will predict the motion. It will say here that under what conditions will there be any change or anything occurring in motion. Okay. So in the force and laws of motion, we study the laws that govern motion. All right. So first of all, we describe what force is, and so first we state what force is and how it's related with motion.
Yes, sir.
Okay. So force, it is an interaction between two bodies it is an interaction between two bodies which tends to bring a change of state.
It's basically a push or a pull, right?
It's a push or a pull, but we'll try to say what it is.
Yes, sir. In a change of state of motion,
Okay, so it is an interaction between two bodies which tends to bring a change of state of motion or
direction,
change of shape.
shape, yeah. So
Which
direction also, right?
yes, that comes under the state of motion.
So what
Okay,
about,
that
okay,
change of
and
motion.
size comes under shape.
Yeah, size and everything, it comes under shape.
Okay, sir.
So force is an interaction between two bodies which tries to bring about a change of state of
State of
motion
motion or
or
change of
change of
shape.
shape. Okay. So if you apply a force on something, what you are doing is
So we're changing its state of motion, direction, size, or shape.
all right. You can say changing the state of motion, or you
Uh,
can say direction
size or change of shape.
or change of shape. All
Yes,
right.
sir. Sir, even the speed can be reduced, right? With force.
That's under the state of motion.
Okay.
Okay. So these are the things of changes which we observe whenever a force is being applied on a body.
Yes, sir.
If you are applying a
This
force, you are
force,
trying to do all this.
sir,
Yes.
sir, is force vector or scalar quantity?
Okay. So what are vector quantities?
Sir, vector quantities are quantities which have magnitude as well as direction.
Which have magnitude as well as direction.
Direction.
Okay, all right. So does force have direction?
Sir, no.
Okay. Suppose someone is we are trying to move a box from one place to another. Let's take here a box and we try to move it from one place to another. All right. So okay, so consider here we have this cylinder here, and suppose we want to move this from one place to another. So suppose there is someone who is applying a force from here. A force F is being applied over here. Okay. So some more force is required. There is another person who can apply some amount of force, which force is also required to make it move. In which direction should he apply the force? From left to right or from any direction he can apply?
Sir, from any direction.
From any direction?
Sir, can you repeat the question?
See, there is some amount of force F which is being applied on this body to make it move.
Yes, sir.
Okay, but it's not moving. Suppose some more amount of, okay, even if suppose it is moving, suppose it's moving. Now here I consider another person applying a force like this. Okay, so this person, let's say there is another person who can apply a force on this, but he is confused in what direction should he apply the force. Should he apply the force like this? Should he apply the force like this? All right, should he apply the force like this in this direction or in this direction?
Yes, sir.
Okay, so this is your option A, B, C, D. In which, if he applies a force in the direction A,
Sir,
what
in
effect?
direction A, it might move, but in direction D, it will move opposite. Like, um, it
Sir, it
in
can't be neutral.
sir, yeah, D will be neutral because both are opposite to each other.
In direction of the motion will the speed will increase, but if
Sir,
in
only in A, I
if
think.
force will be neutralized, it will be
Only in
balanced. Sir, only in A.
Yeah, only in A, sir. Because same direction.
Only in A.
Yeah.
Okay. So see, so is there any effect of direction of applying the force?
Yes, sir.
Yes.
Yes, sir.
So should force be a scalar quantity or a vector quantity?
Sir,
Vector.
vector.
But
Okay. So now you got your answer?
Yes,
yes, sir.
sir.
All right. So I think a doubt is clear that force is a vector quantity. All right. So we can move further.
Yes, sir. Why not?
Uh, So see, force is something which tries to bring about a change of state of motion, or it can change the state of direction, okay, shape of the body.
Yes, sir.
If suppose I apply the force D, so if I am applying the force D, I may be able to change the shape. It may get compressed. Okay, if I am applying a force A, it may get elongated and it will make it accelerated. All right. So now we'll study the effect of the forces, what all a force can do. Whenever we apply the force, so it can change the speed of a body, it can change the state of motion,
Shape,
like it can,
size, direction, or motion.
okay. So it can change the size of the body, direction of motion of the body, or the shape of the body can be changed by
Sir,
applying
it
some
can
amount of,
cause a body that is moving to stop.
it can cause body,
Sir, it can cause a moving body to remain stationary. Right, sir?
right?
Like, for example, we kick a football, and
Hmm.
when your leg applies a force, it stops the football from rolling on the ground.
Yeah. So that are the different changes which can be brought about. Now the types of forces we see here, on the basis of the resultant, we have balanced and unbalanced forces.
Yes, sir.
Okay. So types of forces on the basis of the
Balanced
resultant.
and unbalanced.
Okay. On the basis of resultant. So on the basis of resultant, there are two types of forces. Either you can have
Balanced.
balanced force and unbalanced forces. So balanced forces are the
Sir,
forces.
the net resultant force should be zero and balanced.
Okay. So you have balanced forces.
Unbalanced forces.
In the balanced forces, the sum of all the forces is equal to zero. So if a
Yes, sir.
number of forces are acting on a body and you say that the sum of all the forces,
Yes, sir.
all the forces acting on a body is zero.
Is zero.
Sum of all the forces acting on a body is
Acting on a
zero.
body is zero.
Yeah. Then the forces are,
Balanced.
yes, then the forces are balanced. All right. Then we have the unbalanced forces. So what
Sir,
are
when the sum
unbalanced?
of all forces acting on a body is not zero, then it's unbalanced.
Yeah, if the sum of the forces acting on a body is non-zero, then we say that the forces are unbalanced.
Sir, for this, can we give an example of pushing a cupboard for
Just
unbalanced force?
I'll tell you everything. Unbalanced forces. If the sum of forces,
Is not zero, then
hmm,
unbalanced force. When it is, then the forces are unbalanced.
yes, if it's non-zero, then the forces are unbalanced. All right. So we'll see some examples where the forces can be balanced, and we'll see some examples where we will tell that the forces are unbalanced. Okay, now consider here different situations. We'll try to predict that whether the forces are balanced or unbalanced.
Okay, sir.
Okay, so here we take different objects. Here we have one object, another object here, another object here. Let's say here are the two forces which are acting on the body. So what can you say about the forces?
So that,
Right? This is your 5 Newton of force. This is also 5 Newton of force.
sir, it's balanced.
Okay. Here again I say, all right, this is also 5 Newton force. This is also 5 Newton.
So
They're
balanced.
unbalanced.
Sir, unbalanced, sorry. No, balanced, sir.
Okay. This is 5 Newton, 5 Newton. So for the first one, A, B, C. What about A? Are the forces balanced?
No, sir.
Yes, sir.
Okay. So what do you think in reality if I'm applying a body of forces in two directions like this? Will
Sir,
it bring about
resultant force will be
any
F2
change?
minus F1.
Will it bring about any change?
No, sir, it will be 0.
Here the forces are not balanced. They are not
Okay.
acting opposite to each other. So the
All right,
object
right. They're not acting
so
opposite.
the object will actually be moving along the direction. If you are applying such a force, so the object will be moving like this. Are you
Oh,
getting? You are trying to push
yeah,
one.
yeah, yeah.
There are two people. One person is trying to push it along towards the right. One person is trying to lift it upward. So it will be moving in both the directions.
Yes, sir, I understood. I got it.
Understood, everyone?
Yes, sir.
Yes,
Okay.
sir.
What about the case B?
Sir, case B is also unbalanced because they're not acting opposite to each other.
Yeah, they are not acting opposite to each other. So the two forces they are adding up.
Yes, sir. Sir,
Okay, so
but option C is balanced because they're opposite and the net force is 0.
okay, for option C, it is balanced.
Balanced.
The two forces are opposite to each other and it's equal. So hence the forces are balanced. Got
Balanced.
it?
Understood, sir. So,
Okay.
sir, for a force to be balanced,
First one
the
is
force applied
unbalanced.
should be opposite to each other, right?
Yeah, this is unbalanced. It's not always there should be opposite. I'll tell you different situations. Here there were just two forces, so you say that they were opposite. They should be opposite. Okay, if there are three forces, then what will you say?
Sir, unbalanced,
No, then they can also be balanced.
balanced, yeah.
Okay, I'll tell you the situations when the three forces can also be balanced.
Yes, sir.
Okay, so this is also unbalanced. Okay,
Yes, sir.
and this one is balanced.
Balanced.
What can you say about this one? These two, I have two more examples you can think of. Okay, so here you have 5 Newton and here you have 7 Newton. What can we say about the two forces?
Sir, there,
Are the two forces balanced?
Sir, in
No,
first
sir.
case,
first one is
unbalanced.
unbalanced.
It's unbalanced. All right, for this one they are unbalanced. And what do you say about this one? 7 Newton, 7 Newton.
Sir, balanced.
Balanced.
Balanced. Okay. So now I think you can find out that which forces are balanced and which forces are
Are
unbalanced.
unbalanced.
So these are unbalanced and these are balanced.
Yes, sir.
Okay. Now, can three forces also be balanced? If there are three forces acting on a body, so can they be balanced? Is there any situation when we can call it to be balanced?
No, sir. No, sir. Yes, sir. If the
Sir,
third
it
force is
can,
zero.
can.
Sir, if the third force is acting perpendicular to the
Perpendicular, yeah.
Okay, I'll show you some forces which are acting. There may be three forces, but they can also form balanced forces. Okay. Like see, show you. So see, here I show you a few forces that are working and still. So consider this body. You have three forces. One of the force acting like this, the other two forces like this. So you consider that there is something, and which I have tied with the help of a rope. So I have tied it with the help of a rope, and there are three people which are applying equal forces with each other. Okay. So is there a possibility that the three forces can be balanced?
Sir, yeah.
Yes. As
Yes,
you
sir.
can see, the net resultant of these two forces is in the downward direction, which may be able to cancel the opposite one. Okay, so it can form a pair of balanced. So even the three forces can be balanced, four can also be balanced, five can also be balanced, but there are situations where it can be balanced and it cannot be balanced. Got it?
Got it, sir.
So, okay, now what the balanced forces can do? What
So
balanced forces
they
can do?
make the body stay at
To
rest.
make the body, yeah,
They make the body?
stay at
Stay at
rest.
rest.
No, it's not necessary. It's not necessary they will make the body at rest.
Sir, the balance forces will continue to be in its state of rest. It's in motion or it is state of rest.
So they will not do anything with motion. Okay, they are not going to alter with motion. Okay, just think this. You have been given a thread. Okay, you are given a thread and two people, they are trying to pull it from two opposite directions. So what will happen?
So there won't be any
Okay, won't the thread break up?
Yes, sir.
yes, sir, because both will be applying different.
Both will be
Yeah,
applying different.
so the people are pulling it, they'll have different forces, right? So it will end up breaking.
Okay, so they will end up breaking it. So isn't it a change of shape and size?
Yeah, sir.
Okay, so balanced forces, they can bring a change of shape and size. What are you doing if you suppose here you have some support, and on this support you put an iron piece, and if you hammer this, so what will you observe?
So we'll find a change in the shape.
Yeah, there will be a change of shape on hammering as the forces were balanced. Okay, the sum of the total forces which are acting over there, they are balanced. Got it? Which two forces are acting? One of the force that I'll be applying is from the hammer from the top direction,
So
and the
then
other
one
force,
which is being applied by the object from the bottom direction.
yeah, from the bottom, the surface will provide a reaction force. So the two forces will be balanced, and hence the object will not go anywhere, and its shape will change. So what balanced forces can do? They can
So they
change.
can cause a change in shape and size.
Okay, so balanced forces can change shape and size. Balanced forces can bring change of shape and size. All right. And then what unbalanced forces can do? So they
Mhm.
balanced forces, they bring about a change of shape and size, no change in the state
The
of motion.
change in okay.
No change in state of motion. There is no change in the state of motion, but there is a change in shape and size. Then unbalanced forces.
So
What
they can cause a
unbalanced
change
forces?
in state of motion and rest or uniform motion, sir. If we take the example of tug of war,
Hmm.
sir, both
Hmm.
the teams will be applying different amount of forces on the rope.
Hmm.
So one team will either move towards the direction of the other team, or the other team will move to the direction of the first team. So
Yeah.
it causes a
So
change in the state of direction.
Okay, so unbalanced forces, they will bring about change of motion. Okay, so there
Change
will be a change of motion. That means there will be an acceleration.
Yes, sir.
Okay, so we'll come across now Newton's first, second, and third law of motion. According to the Newton's first law of motion, every object continue in its state of
State of
motion.
rest unless an external force acts on it.
It's
Unless
not
the
necessary to be in the state of rest. So according to Newton's first law of motion,
object
every object continue to be in the state of rest or of
Sir,
uniform
of
motion.
uniform motion along a straight line path unless an external force is applied on it.
Okay, so every object remain in the state of rest or of uniform motion in a straight line unless acted upon
By an external force.
unless acted upon by an external force, by an external unbalanced force. Okay, so the force should be unbalanced. Okay, so the force should be external unbalanced force. Then we can say that according to the first law of motion, the object will remain in the state of rest or of uniform motion. All right.
So
So
this
what
is
it means?
also, yes, sir.
So according to the Newton's law of motion, it means that if there is no force acting on a body and the body is at rest, so it will remain at rest continuously.
Unless some external force is applied on it.
Yeah, unless some external force is applied on it. So, and if an object is moving, so it will keep on moving, or it will continue to move in the same way with the same
Well,
speed,
yeah.
unless it will continue to move with the same speed in the same direction, unless some external force is acting on it.
Yes, sir.
Okay, so that's the Newton first law of motion. We describe here different examples, different things with the help of the Newton's first law of motion,
No, yes, sir.
like the falling of fruits.
So that is due to the inertia of rest.
Yeah. So falling of fruits is an example.
Sir, when a person is sitting in a bus, he falls forward when the brakes are applied.
Yes. So falling of passengers in a bus. All right. Falling of passengers in a bus. All these
Sir,
are
luggage is tied on the roof of a bus with the rope.
yes. Falling of
Tied
passengers.
luggage.
All right. So
Sir,
all these
beating
are
a carpet.
okay. All these are examples of Newton's first law of motion or applications of the Newton's first law of motion.
Okay.
Then we state the Newton's second law of motion. So I think there are a lot of people in my class who are just sitting. I want them to answer. Yeah, Vidya Varun.
Yes, sir.
Okay, state Newton's second law of motion. Do you remember Newton's second law of motion? Niharika? Niharika, can you state Newton's
Yes,
second law of motion? Yeah.
yes, sir. So Newton's second law of motion states that acceleration of an object depends on two things: the force acting on an object and the mass. So the formula is F equals m into a. So force equals mass into acceleration.
Okay, you are correct, but this is not the statement of the Newton's second law of
Sir,
motion. You are partly correct. Okay. So according to the Newton's second law of motion, the
sir,
force acting on a body, yes,
the rate of change of momentum of an object is directly proportional to the applied external force, right?
Okay, so the force acting on a body is directly proportional to the rate of change of momentum.
Yes, sir.
It is directly proportional
Rate of change of momentum.
to rate of change of momentum, right? So now, so before we proceed, we should be aware of what is momentum. Okay. So momentum is represented as product of mass and velocity.
P is MV or MA.
So what is momentum? Momentum, it is P represented by the symbol P, and it is the product of mass and
Mass
velocity.
and acceleration, right, sir?
No, mass and
Oh,
velocity.
sorry. Yeah, mass and
The
velocity.
product of mass
Mass
and
and
velocity.
velocity.
Also, it is a vector quantity. So you'll write the momentum P to be equal to m multiplied with P.
V.
The direction of momentum is same as the direction of velocity.
Velocity.
Okay, since it's a vector quantity, so it must have its direction, and direction of momentum
Sir,
is,
so can we say that momentum is directly proportional to velocity?
yeah,
Yes,
the
sir.
direction of velocity. So momentum is measured by both the quantities, mass and velocity. Okay, so
So,
if you see, you have a heavy object and a light object, both of them are moving with the same velocity. So heavy object will have a greater momentum.
Yes, sir.
sir, so mass is directly proportional to velocity, right?
Yeah, what happened?
Sir, so mass is directly proportional to velocity, right?
Mass is not directly proportional to velocity. Momentum is dependent on both the things.
Okay.
Momentum is proportional to mass,
And
momentum is
momentum is
proportional to
proportional to
velocity.
velocity.
Sir, like if uh, the mass increases, the momentum also increases.
Yeah.
Yes. If the mass will increase, the mass will be higher, momentum will also be
Okay.
higher. And along with mass, it also depends on velocity.
Velocity. Sir, if velocity increases, momentum increases.
Mm.
If velocity decreases, momentum decreases.
Yes, if velocity decreases, momentum will decrease. Now, so SI units of momentum, they are,
Meter per second.
yeah, mass will be measured in kilograms. So you have kilogram meter per second. The amount of force will be measured as change of momentum per unit time.
Delta
Delta
P
P.
by delta T.
So as by the definition, the force acting on a body is directly proportional to the rate of change of momentum. That is why we can say that momentum will be proportional, force will be proportional to, or force will be equal to the change of momentum per unit time. Now, the change of momentum is measured to be final momentum minus the initial momentum. Whenever we measure the momentum, we measure it as final momentum minus the initial momentum.
Got it, sir.
Okay. So delta P is the change of momentum which we measure delta P to be,
PS minus PI, right?
okay, final momentum minus the initial
Initial
momentum.
momentum.
Okay, so the final,
By time, right, sir?
yeah, obviously, just change of momentum will be final minus initial. So the force would be change of momentum P5 minus PF minus PI divided by delta T. All right. Now by solving this, okay, we see here, let's see, the final momentum PF will be given by the formula mv. The initial momentum will be given by the
MU.
formula mu. So a change of
Sir,
momentum
so we
delta
can
T.
do M, we can take M common, so we get M into V minus U by T.
Okay. So change of momentum will be given as mv minus mu, final
Mu by
momentum
T.
minus the initial momentum. Therefore, using the formula of force, we can write
M
change of
into V minus
momentum
U.
per unit time, which can be written as mv minus mu over delta T. You can take out mass common and you write here v minus u over T, delta T. We know that v minus u over time is acceleration, so this is the same as mass times acceleration. All right.
Yes.
So this was what Niharika said. Niharika.
Yes, sir.
Okay, but the problem is that why we can't directly say that force is directly proportional to we can't directly say that force equals to mass times acceleration, as mass is also not a constant quantity.
Okay,
For
sir.
here, for under the normal situations, we have mass as constant. Okay, but mass is also variable quantity under certain or other condition. Okay,
Okay,
under
sir.
the relative conditions, like when an object moves with very high speeds. So in those conditions, we have mass as a variable, or you have a variable mass system like movement of a rocket. That is a variable mass system. Okay.
Got it, sir.
Okay, the fuel of the rocket decreases continuously. So you can say that the mass of the rocket is decreasing. So over there, F equals to ma will not be valid. Over there, we need to apply force will be equal to change of momentum per unit time.
Yes, sir. Got it.
So what is the SI unit of force?
Sir, Newton.
Newton. The SI unit of force is Newton. And what is the CGS units?
Dying.
Sir, dyne.
Dyne. Alright. So we have the CGS unit as dyne. SI unit as
K. Newton.
Newton. Alright. So SI unit we observe
Newton.
Newton. SI unit will be Newton. Denoted by F. It's equivalent to kilogram meter per second.
Yeah.
But kilogram meter per second square, that's the same as force.
Force.
Right? So this is about the second law of motion. The second law of motion tells the force F which we have written over here is the net force. Okay, so you can say like this, that the net force will be equal to mass times acceleration. The force which we have written over here is the net force. It's the net force. Okay, like we have a question based on this in your book also, something like this. You have a question of a railway wagon. You have a question like this, or you just consider a simple question which consists of a bus over here. So the bus has, all right, so we have the bus which is moving with, right. Okay, so suppose here what are the forces acting? Suppose the engine of the bus is applying a force of 8,000 Newton.
Hmm.
Okay, the engine of the bus is applying a force of 8,000 Newton, and there is a force of friction being offered by the ground, and consider the force of friction to be just 500 Newton. All right. Suppose the mass of the bus M is 10,000 is 50,000 kilograms. Okay, 50,000 kilograms. Okay, so what would be the acceleration of the bus?
Sir, PF. Yes, sir. Sir, first the force will be 7,500 Newton.
Force will be
So,
7,500 Newton.
so M is given as 50,000 kg. Sir, is the bus in a state of rest?
In whatever state it be, you just have to find the acceleration. The force is given to you.
Sir, is the acceleration 0.5 meter per second square?
Acceleration 0.5.
5 meter per second square.
Okay, so see, we find out the acceleration A to be equal to F over M. We know that force is equals to mass times acceleration, so we can obtain acceleration to be equal to force over mass. The force, which force we will be including? Should we include 8,000 or something else?
So 7,500.
Sir,
Okay, the net force. F here is the
Net
net
force.
force. So you have the net force acting as 7,500.
sir, engine applies 8,000, I hope. 800.
Its engine is applying 7,000 and there is a force of friction of 500 Newton. So the net force acting on this is 7,500 Newton. So 7,500 Newton divided by the mass, which is
Sir, I'm
50,000.
getting 0.5.
Okay, so it's not 0.5.
Sorry, 1 second, sir.
3 over 2, that's 1.5 meter per second.
Yeah,
One point-
1.5.
Got it. So acceleration of the bus is 1.5 meter per second square. Got it?
Yes.
Okay. So, can
Sir,
you tell?
7,500. No, not 75,000.
Hmm?
Sir, it's 7,500, no?
Okay, it will be 7 point. Yeah.
It's 0.15.
Okay. 7,500.
So we'll
It is
get
0 point.
7,500 by 75 by 500, which is 3
All
by
right.
20.
Okay. 0.15.
Yeah.
We are getting the acceleration
0.15
at
kg meter per
0.15.
second. A meter per second, sorry.
Yeah, it's 0.15 meter per second square. Got it?
Got it, sir.
Okay. So now, can you find out its final velocities?
Yeah, sir.
Okay. So we'll do some questions based on this. Just now today we are doing all the concepts of this chapter. Okay. So we have done Newton's first law, Newton's second law.
Yeah.
Okay. Now we know Newton's third law of motion. So according to the Newton's third law of motion,
Every action has an equal and opposite reaction.
yeah, for every action there is equal and opposite reaction. Okay. The third law of motion. According to the third law of motion, for every action,
There is an equal and opposite reaction.
there is an equal and opposite reaction. Right? So for every action, there is an equal and opposite reaction. Now here, action and reaction, they are the forces. Okay, the words action and reaction have been used. They are the forces. All right. So for every action force, there is a reaction force. And either of them can be the action force. It's not just that only one of them will be the action force, the other will be the action force. Right. So either of them can be action and reaction forces.
Yes, sir.
Now see, how does action and reaction occur? Try to understand with a number of concepts here. Suppose you have ice. So here there is ice. You are in Antarctica now. You are feeling cold. And suppose you try to push something. Suppose you have a heavy mass over here, a stone, and you are trying to push it. Okay. So if you try to push it, what are the things that you will experience?
Sir, it will exert an opposite force.
Okay, it will exert an opposite force. So will there be any change on your body?
Sir, can you tell the example once more?
Okay, so you are in Antarctica, you are trying to push a heavy object.
Okay.
Okay. So what will happen?
Sir, the pushing will be the action force,
The pushing will be the action force.
and
Then,
the force which returns to us by the force being returned by the block towards us is the reaction force.
okay. So the person will, or if I'm trying to push it, I will be getting a
Action. You will be
reaction
giving the
force. Okay,
action force towards the block, and the
okay.
block will be giving you the reaction force.
Okay, so suppose this is I standing over here and I'm applying a force on this. So I'm
Yes,
applying
sir.
a force like this. So as a result, I will get a backward force like this. I will
Yes,
get
sir.
a force
That's the
from this in the
reaction
backward
force.
direction. I am applying a force on this ball in the forward direction. So I will be getting a backward force. I will slip off in the backward direction.
Yes, sir.
Okay. Since I applied a force of action on the ball or on
Sir,
this
the
mass,
reaction force will cause the reaction force will make you fall down because yes,
yeah, so the reaction force will
it
make
will
you
push you
fall.
backwards.
Yeah, so the similar thing will happen if you are suppose if you are wearing the roller skates, since we can't go to Antarctica right now. And if you
Yes,
have
sir.
your roller skates, you can wear your roller skates and try to push the wall.
So
Okay.
you'll still slip backwards only, right?
Yeah, again you will slip backwards. Okay. So the reason being that there will be a reaction force offered to you. Your body will experience a reaction force in the backward direction. Got it?
Got it, sir.
Okay. So for every action, there is a reaction. Suppose if you, okay, you can take an example of a spring balance like this. Suppose uh, I take two spring balance over here.
Yes, sir.
So yeah, I'm taking two spring balances. I hope everyone knows what a spring balance is.
Yes, sir.
Yes, sir.
Okay. So this, with the help of spring balance, can we measure the forces?
Yeah,
Yes, sir.
sir.
Yes. So with the help of spring balance, we can measure the forces. All right. So here we have spring balances, and it has its indicator over here. So it will indicate the amount of force as well as the amount of mass that is hanged on it. So suppose from this spring balance, I am making here, this is the spring of the first one. So I have made a hook over here where I can attach the second spring over here. All right. So if suppose the first spring over here, it shows you a force of, let's say, 5 Newton. It shows you a force of 5 Newton. So what will be the force shown by the second spring?
Sir,
Will
5
this
Newton.
will this be 5 Newton, less than 5 Newton, or greater than 5 Newton?
Sir, 1 second. Yep. When you pull it, sir, less than 5 Newton, I think.
Okay, less than 5 Newton.
Sir, because when we pull it with the spring which has 5 Newton, it will move forward.
Hmm. All right, so it will move forward. Okay. So both the springs, they will show the same amount of force in accordance with the Newton's third law of
Third law
motion.
of motion, yeah. 5 Newton
That that every action will have
have
equal
an
and
equal
opposite.
and opposite reaction.
Right, so since every action has equal and opposite reaction, so it will show it. All right.
Yes, sir.
Okay. Okay, so any doubts to anyone with all the three laws of motion?
No doubt, sir.
No. Okay, so you have one more thing, that is which we call as, only one topic is left from this chapter, that is conservation of momentum. Okay, once we do that, then we'll be in the next class, we'll be doing with question answers of this chapter.
Yes,
Question
sir.
answers, some practice questions. Yes. All right. So just go through the topic conservation of momentum. The conservation of momentum, it means that the total initial momentum should be equal to the total final
Total
momentum.
final momentum.
Okay. And if no external force is applied on the
Yeah.
system. So if no external force is applied on the system, you will say that the total momentum remains conserved, which you remember the formula as m1 u1 plus m2 u2 to be equal to m1 v1 plus m2 v2. This was the formula which we use whenever there is a two particle system. So you have a two particle system and there are some interactions happening among them. There is no external force applied on them. So you observe m1 u1 plus m2 u2 to be equal to m1 v1 plus m2 v2. Got it? Okay. Bye everyone. Good night.
Sir,
Thank you. And yes.
sir, my final exams are from 1st Feb.
Yeah, before that we are trying to revise at
Yes, sir.
maximum we can. See,
Sir,
we revised this whole
they
chapter in one
removed,
day.
yes, sir. Sir, they actually removed conservation of momentum for us. They didn't teach us only.
Okay, nothing. So I haven't told you much. It's just the formula. Okay.
Sir,
All
could
right.
you please send some sample papers if you have them?
I'll just check.
Yes, sir. Thank you,
Yes.
sir.